Hello, I'm John. I'm going to be doing the 2009 AP Calculus AB free response question number 2. This problem states the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t equals 1,380t squared minus 675t cubed for 0 is less than t is less than 2. So 0 to 2 hours for t. R of t is measured in people per hour, so you know it's a rate. No one is in the auditorium at time equals 0 when the door is open. The doors close and the concert begins at time t equals 2. Okay, let's start with part A. This asks how many people are in the auditorium when the concert begins. This means that we're going to need an integral from time equals 0 to time equals 2 of r of t times dt. Don't forget that dt because you'll lose your one integral point on this one. So this means that the integral is 0 to 2 1380t squared minus 675t to the third dt. Now, if we plug this into our calculators, it's going to be a little bit tricky if you don't have an advanced enough calculator. This is the Inspire CX. It is pretty good for this kind of thing. You can hit this button, go to this menu, select the integral option, go 0 to 2, and then plug in your function. X squared, we're just going to use x for simplicity's sake, 675x raised to the 3 dx, and then you will get 980 people have entered in this time, so your answer is 980 people. Make sure to include that unit. Alright, now on to part B. Part B asks, find the value when the rate at which people enter the auditorium is a maximum, justify. So the work we're going to do is going to justify, but this means it's a max or min problem, so using the extreme value theorem and all that, we're going to have to find where the derivative of this function equals 0, and then plug that in with the endpoints, plug those all into the original function, and find which one is greatest. So the original function, or the rate, is 1380, that's about 8, 1380t squared minus 675t to the third. So the derivative of this is 2760t, because it's just power rule, minus 2025t squared. When we set this equal to 0, we can do some factoring, get t on the outside, 2760 minus 2025t equals 0. That means that we have a t equals 0 for this one, but that's irrelevant because 0 is already one of our original values. So then we got to set 2760 equal to 2025t. Then when we divide, we get t equals 1.3629 dot dot dot. Alright, so with this, that means that we have to plug in all of our values. So we have 0, 1.363 or approximately, and 2. This means, or once we plug these all into our function, we get 0 for, r of x, 0 for 0, it's kind of a wacky value, 854.527 approximately for this one, and for 2 we get 120. Since this is clearly the largest value of our original function, that means that the maximum values achieved of the rate at t equals 1.3629. Okay, now on to part C. So part C says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function w models the wait time for all the people who enter the auditorium before time t, and the derivative of w is given as w prime of t equals 2 minus t times r of t, which is our function from earlier. Okay, so it wants you to find w of 2 minus w of 1, which is the total wait time of everyone who entered the auditorium after time t equals 1. So it's not from 0 to 2, it's from 1 to 2. But so this is a little bit wacky because this is a derivative of a function that we have to go for. But since we have the derivative and we're trying to find the full value, we can just turn it into, or we can just integrate this. So we can integrate from 1 to 2, you gotta remember that, of 2 minus t times r of t, which is 1380t squared minus 675t cubed. And then dt, you gotta remember that, they're all sticklers about it at the AP area. So basically you're just going to want to plug it into your calculator. You know, mine has the magic integral button. I'm not really sure how you would do it. If you don't have that, I guess you'd have to integrate by hand and plug them in. But from 1 to 2, and then your function 2 minus t times 1380 t squared minus 675 t to the third dt. So the value we get out is 387. The value we get out is 387.5 from our calculator, you can see. And so basically what this is hours. This is just an average value for all the people, so the unit you'd want to include is just hours. Alright, now for the final part, part D. This is kind of the culmination of everything we did before. It asks, how long does a person have to wait on average in the auditorium for the concert to begin? It asks you to consider everyone who enters the auditorium after the doors open and use the model for wait time for part C. Alright, so this one's a little bit different from part C, the integral that we're going to have to use, because it actually goes from 0 to 2. If you recall from part T, it went from after time equals 1, so that was 1 to 2. This one, it's going to be everyone who enters, so from 0 to 2. And then we're going to have to use our value from part A. If you recall, it is 980 people total entered. That's an 8. So we're going to just divide the total wait time we get from our integral by this value of 980. So here is the thing for our average. 0 to 2 of our integral 2 minus t times 1380 t squared minus 675 t to the third. All this dt, don't want to miss out on that point. Alright, so if we plug this into our calculator, once again, we're going to use the button for the menu of options, then hit the integral button. Then we're going to have to go from 0 to 2 and then plug in our value 2 minus t times 1380 t squared minus 675 t to the third, if you can see that, and then all of this dt. So then that means that that's the total number of hours waited by everyone. So everyone who waited contributed to this value, so that's 760. And so this is the total number, and so there were 980 people, so we have this on the outside, so it's just 760 divided by 980. If we do this calculation, we get approximately 0.77551. So this means this is hours. So this is the total or the average number of hours waited by everyone. So this is kind of just the grand culmination of everything that we had to practice before. So yeah, there's your answer. Alright, closing thoughts. So this problem wasn't too crazy hard. I mean, if you didn't really recognize what it's asking you to do, I can see how you just get lost. But if you can see, you really just have to pay attention to the wording, how many people are in there when it begins, or find the time at which people enter as a maximum, the rate, stuff like that. You gotta just make sure you're reading the question a couple times yourself before you really jump in. This one, there aren't many like this in the book, because this one's kind of giving you a word problem with a function and a rate that you kind of have to go backwards or go forwards from there. So I couldn't really find anything good in the book, but I think the 2002 number 2 problem that we did, FRQ, it's kind of similar. This is like a plus rate and a minus rate, and you have to compare it, so I would say that this one's probably harder. So if you want to give yourself some good practice for this kind of thing, that's usually a good idea. Thanks for watching.